Hello friends, here in this video we will see a problem on welded joint for some given conditions, and for this purpose here we have a question. Determine the length of weld run for a plate of size 120 mm wide and 15 mm thick to be welded to another plate by means of a single transverse fillet weld, double parallel fillet welds when the joint is subjected to variable loads. Take sigma T tensile stress as 70 megapascal and tau, that is shear stress, as 56 megapascal. So this is the question we have. Whatever is given here, first we need to write that in the form of data. So for this question we need to write the data. Now I'll read whatever is given here again. Determine the length of weld run for a plate of size 120 mm wide and 15 mm thick. So width W is equal to 120 mm, thickness S is equal to 15 mm. To be welded to another plate by means of single transverse fillet weld and double parallel fillet weld. So for this case here I'll explain it by drawing a diagram. Here we are having two plates. Which are joined together by welded joint. Now these are the two plates. Now how they are connected? They are connected by single transverse fillet weld and double parallel fillet weld, like this. So here is the diagram, and these plates, they are subjected to load in this way. I am considering tensile load. Now in the question width is given, so the width of this plate here, this is 120 mm, and the thickness of the plate is given as 15 mm. Here we have to determine the length of weld, that is the question. So the length of weld means we have to find out how much is the length of transverse fillet weld. Length of transverse fillet weld, this length will be denoted by L1, and next we have to calculate length of parallel fillet weld, that will be L2. So these are the two questions. We need to know how much is the length of weld, and they have given that the joint is subjected to variable loads. See, variable loads means this condition means that it is subjected to fatigue loading. So here we have to find out for fatigue loading the values of length of each weld, and then they have given the values of stresses. Sigma T tensile stress is 70 megapascal and tau shear stress is 56 megapascal. So this is the question we have. Now let us try to get the solution for this problem. Everything I have written in the form of data. So let us get started with the solution. The first thing I'll say that since length of single transverse fillet weld. This length is given by L1 is equal to, now from the total width, since the width is 120 mm, it is parallel to the length. So from 120 I will subtract 12.5 to get the value of L1. Therefore L1, it comes out to be 107.5 mm. So with L1, here is the first answer. That is the length of single transverse fillet weld. Now we need to calculate the length of double parallel fillet weld, and for that what we need to know is how much is the value of this load, because in this problem the load P is not given, we have to calculate. So I'll say that since total load acting on the plates, that total load is P, and we need to know the maximum load. So load is basically stress into area, and if we compare the stresses sigma T and tau, that is tensile stress and shear stress, tensile stress has more value, so we need to select this. So here I'll write down area multiplied by tensile stress, because we want maximum load, so we have to take the maximum value of stress. Next, from this, area width is 120 and then the thickness is 15, sigma T is 70. So here I get the answer of total load, which comes out to be 126 into 10 raised to 3 Newton. Now after getting the value of load, the next thing which I need to calculate, that is how I am going to get the value of L2. For that, as we have single transverse fillet weld and double parallel fillet weld, we will be calculating the load carried by single transverse fillet weld, load carried by double parallel fillet weld, adding both the values of load and equating it to the value of P, and then when we will get the final answer. So here I'll say that since minimum thickness in weld, that is equal to throat thickness. And what is throat thickness, that I can explain with a diagram. Here we have S as the thickness of plates. These are the thickness of plates. Then I'll name this triangle as triangle A, B, C. Then I'll draw a perpendicular to this hypotenuse AC, and this perpendicular I'll name it as BM. So BM will be called as the throat thickness or the minimum thickness. Now since I'll say that the minimum thickness in the weld, it is the throat thickness, and therefore throat thickness will be BM, and I'll denote it by T, that is small letter T. Now see, if we are considering welded joint, in welded joint failure will always take place at minimum area. At the throat we are having minimum thickness, so minimum area will be throat thickness multiplied by the length of weld. So therefore minimum area at the throat, that is A, is equal to T multiplied by L1, since we are finding for transverse fillet weld. So therefore area is equal to this thickness, throat thickness, we can get it from this geometry. Here this angle is 45 degree. So in this triangle AMB, I can say that sine 45 degree will be equal to throat thickness BM upon this hypotenuse AB. So therefore sine 45 will be equal to BM is T, AB it is S. So therefore here I will get T is equal to sine 45, which is 0.707 into S. This is the value of throat thickness. So throat thickness is 0.707 into S multiplied by L1. Now in this I can say that after reaching here, next, then once I have got the minimum area at the throat for transverse fillet weld, I'll say that therefore load carried by transverse fillet weld, that load will be denoted by P1 and it will be area multiplied by tensile stress, because transverse fillet weld is subjected to tensile stress. Now I will keep this as my equation number 1. Here sigma T is given as 70 megapascal, but we cannot use this value directly because the condition is given that we have to use fatigue loading condition. So this sigma T will change. So I'll say that since for fatigue loading stress concentration factor for transverse fillet weld, this stress concentration factor will be, for transverse fillet weld the value is 1.5, and similarly stress concentration factor for double parallel fillet weld, it will be equal to 2.7. So these are the stress concentration factor, and with the help of stress concentration factors we can find the new values of stresses. So therefore tensile stress sigma T will be equal to 70 divided by 1.5, because this is for transverse fillet weld and transverse fillet weld is subjected to tensile stress. So sigma T, this comes out to be 46.7 Newton per mm square, and shear stress tau will be 56 divided by 2.7, and so this value is 20.74 Newton per mm square. So after getting the values of stresses, now I can put the value in equation number 1 to get the load carried by transverse fillet weld. So therefore put sigma T in equation 1. So here I have P1 is equal to area, it was 0.707 multiplied by S into L1 into sigma T, we have got the value as 46.7 for fatigue loading. So therefore P1 will become S is given in the question, that is 15, the thickness of the plate. L1 we have calculated at the start, it was 107.5 into 46.7, and from this the answer of P1, it comes out to be 53.24 into 10 raised to 3 Newton. Now after getting P1, I can say that load carried by double parallel fillet weld, that load will be P2 is equal to area, and since we see here that in case of double parallel fillet weld we have two areas, so it would be 2 into A multiplied by stress is tau, so area multiplied by stress gives us the load, and here 2 into area will be same 0.707 into S, as because the throat thickness is same, but here length will change, it will be L2 into tau, so therefore P2 will be this. If I calculate, it is 2 into 0.707 into S is 15, L2 is what we have to calculate, tau is 20.74, so I'll get P2 in the form of L2, and my answer is therefore P2 comes out to be 440 L2, and this unit is in terms of Newton. Now once we have got the value of P1 and P2, I can say that hence total load P is equal to P1 plus P2. So therefore this total load we have calculated earlier, its value was 126 into 10 raised to 3 is equal to P1, it is 53.24 into 10 raised to 3 Newton, P2 it is 440 L2, so therefore if I simplify this, L2 will be equal to 126 into 10 raised to 3, this term will go into left hand side, so minus 53.24 into 10 raised to 3 divided by 440, so from this I'll get the answer of L2, which is 165.4 mm. After getting L2, I can say that adding 12.5 mm in L2 in order to consider start and stop of weld. Now here I am adding 12.5 mm in L2 in order to consider start and stop of weld. So therefore the new value of L2, it will be 165.4 plus 12.5. So my answer of L2 comes out to be 177.9, which is very close to 178 mm. So we will consider this length. Our second answer. So here if we look into the question, they were saying us to calculate the length of transverse fillet weld, length of parallel fillet weld. Length of transverse fillet weld, we have got the value as 107.5 mm. Next, the length of double parallel fillet weld, it is 178 mm. So here we have designed this welded joint completely by finding the length, and so if I draw it on a diagram, then I can explain it with a diagram. These are parallel fillet welds. This is the transverse fillet weld. So we have calculated their length. Now, so here as we see, this will be L1, that is the length of transverse fillet weld. Answer was 107.5 mm. Then the length of parallel fillet weld, L2, it is equal to 178 mm, and this is the width of the plate, which is 120 mm. So here this completes the design of the welded joint, where we have completely designed the joint which they have given by considering transverse fillet weld, which is single, and double parallel fillet weld, and with this we complete the problem.